Hello and welcome. Today I want to share a state machine that I made to use in Unity projects. This is a very flexible state machine. I will demonstrate how you can create new states and initialize them. Uh, so first I will demonstrate how it's currently working here. So let's play. So as you can see here, this is the default player state machine states that I created. Here I got the player idle state, the movement, and the jump. And here I also got the end state definition. That means that uh, this we can jump to this state at any time uh, uh, if these conditions are true. So as you can see, I'm currently in the idle state, but I can go to the movement state if I'm trying to move. So if I move here, you can see that I jump to the movement state. And from the movement state, I can go to the idle state if I'm not moving. So that's what happens. If I move, I jump to the movement. And if I stop moving, I go back to the idle state. And here on the jump state, this is the setup for the jump state. I can go for to the idle if I'm ground, but since I'm not on the jump state, uh, this condition here is not running. But this is checking if I'm trying to jump and if the player is ground. So the player is on the ground, but I'm not trying to jump. That's why we didn't jump to the jump state. But if I press the jump space bar, you can see that I jump, and then once I hit the ground, I go back to the idle state. As you can see, like this. And of course, you can change this. For example, if I remove the is ground, I can jump in the air. That's not the behavior I want, but just to demonstrate how easy it is to change the behavior of your game by just changing here on the script table. So I can add here and check this box. All conditions need to match, because if I don't check this, it will evaluate any of these conditions. So if this one is true and this one is false, it will return true because it's checking any condition. That's why I checked this uh, box right here. And the same thing goes to the other states. So of course you don't need this. You can remove, and I can add only for the, let's say, for the movement state. So I can only jump if I'm moving. I can add here. I can add the is ground and is trying to jump. All conditions needs to match. And if I hit play, I can't jump if I on the idle state, but if I'm moving, I can jump. Alright, just to demonstrate how easy it is to create and configure your state machine. Of course, this is just one state machine setup. You can have one for like uh, development player state machine states, where you can have like uh, fly state for debugging. And the same thing goes to the parameters. Here I got the states parameters, like the movement speed, the jump height, and also the transition, where the ground layer for the player's ground transition. So I can also have uh, development state machine parameters and like increase this movement speed. Then here on the player, I can just change the state machine parameters to use the development one, like this. And if I hit play, you can see that I'm running much faster, and that's how you can do to easily swap between state machine parameters and states. All right, so I will start showing the, let's say, the main component here, that is the entity component reference. Uh, this basically consists in the read-only dictionary where we have cached components like the rigid body, box collider. Uh, you can see that if I try to get the component, it will try to get inside the dictionary, and else it will get the children. This is just to speed up the get component process for the state machine. So this is the entity component references. Of course, you can use this in whatever place you want, in your normal components as well, but I'm using here on the state machine. So now go to the state machine scripts, and I'll just start from the definitions here. This state definition basically consists on a base state, like the idle state right here. This is a state definition. This blue selection here is state definition. And I got the base state. I got the state transitions. And the state transitions also have a transition state where I can, for example, go from the idle to the movement. And the conditions and the bool if needs to match all conditions. And so that's what state definition is, just a base class for the state and the transitions. And for the any state definition, it's kind of the same, but here I just got the transition, where I got the transition state and the transition conditions, because we don't have a, a base state for the any state definition. This can jump for any state. That's why we don't need a base state. And here on the transition condition base, we basically got a bool method where we can check if we can transit or not. For example, this one player is not moving. I just check if the player velocity on the Y, it's actually player is not jumping. Yeah, if the velocity on the Y is approximately to 0. Of course, you can have whatever condition you want here, but in this case, I just added this one to check the velocity. And I also got some other conditions here. For example, this one, player is trying to jump. I check if the player jump action was pressed this frame. So this is evaluated every frame, so that's why I just checked this condition here. I can also remove this. So that's basically the base class for the state definition, for the end state definition and the condition. And here I got the state machine, where I basically get everything together and run the script. For example, just get the entity component reference and add right here to initialize the states, add the conditions, and Then I instantiate the StateMachineStates. This is because we can uh, we can change uh, at runtime and not change the actual scriptable object, the base one. And here I got the initialize, where we instantiate every state and every transition. And I also got the current state, where on the update, I call the on update, on fixed update, I call the on fixed update. And here on the late update, after running the update, I check if we can transit to any state and to another state inside the current state transitions. And here on the StateBase, I got the state transitions, the setup state method, the parameter, and the empty methods where you can override. So, for example, here on the setup state, I got the StateMachineParameters and the EntityComponentsReferences. So I can go, for example, to the let's say jump state. I can get the rigid body, the animator, the jump state parameters, and initialize the jump force here. And once I enter the state, I can remove player from ground here. I can play the jump animation and then add the force for the rigid body. That's basically how the jump state works. It's all inside the on enter method. And this class right here is the actual parameter for the jump. So you can see that it's serializable, and I got run parameter right here, jump height, where I get from here. So here is the state machine parameters. Basically, I got this reference to the state machine states, where I can, for example, get all the states right here and serialize the classes where the parameters are and change right here. And this is very useful, like I said, to create like the other parameters that you want for different situations or even at runtime. Of course, you would need to adapt this to change, but it's basically doing the same thing. But once you create the parameters and override the method to return one, here I'm returning the new player state parameters, but the default one is no. Alright, so inside the state machine parameters, I can get the parameters of the key that I passed. In this case, the player jump state parameters type. And here inside this int iter, I basically got the state machine state, where inside the onValidate, I loop through all the states, check if it's no, get the parameter, also check if it's no, and I basically collect all the state parameters and add inside the dictionary without repeating the parameters and the states, and add right here so that we can get inside this method. And the same thing happens here inside the transitions. It's the same thing, but in this case, the parameters for the transitions. And I also do something similar here, but in this case for the states, where we can repeat the state. For example, I can go to the idle state inside the movement and also on the jump. So to avoid creating like multiple idle states, I just cache them right here. Doing the same thing, looping raw the setup list and caching the state definitions and the AnyStateDefinition. And this methods right here is basically for initializing the state machine. And here on the onValidate, I basically call the onValidate inside all the state machine parameters, transitions, the state definitions. This is because we can add the name here, so it's easier to visualize. For example, this is the idle state. We can hide this and check here the movement, jump, idle. So that's basically how the state machine works. You got the definitions and the actual state machine. And as you can see here, this is not like a specialized version of the state machine, like for the player or something like that. You can use this state machine for the player, for the enemies, and whatever uh, entity that needs to be updated, like a state machine on the update, fix update. You can use this script without specializing this class. That's why it's sealed. Of course, you can remove this and implement your own, but uh, I don't see any use for that. At least for now, I think we can create a hierarchical state machine. Uh, but this one works fine for now. That's why I made like this. All right. All right. So to make this editor right here, I created a custom script for both parameters from the states and the transitions, where I basically just create property fields for them so that you can't like add or remove from the list. You can just change the properties. That's very useful to avoid the reference and breaking the list when changing the parameters, so that you can't actually add or remove here. It's getting from the state machine definition setup. That's why you can't add or remove inside the parameters. It's all the information that you have here. It's inside these states. So, for example, I don't have a state idle state parameter because I didn't override the method, but I could add one right here and return like I did with the jump state, for example, like this. And the same thing applies to the transitions. The only transition that I have here is the ground. That's why I have this ground layer transition parameter right here. So yeah, to create a class of StateBase, you basically need to just create a class and inherit from the StateBase, where it will also inherit from the Scriptable object. And the same thing applies to the transitions, where it can just inherit from the TransitionConditionBase and inherit from the Scriptable object. So yeah, that's it for this state machine. I'm using here on the Goblins game. I was actually using an older version, but where I actually had a specialized version for the state machine, but it wasn't necessary. It was causing a complex problem, and I just refactored and made this state machine right here. So it's very useful to use in any entity that I'll be creating, like the enemies and of course the player. And to add, remove, or change states, behaviors, it's very easy right here, just inside this inspector. And of course, you can create multiple states definition setups here. So yeah, that's it for this state machine video. I just wanted to demonstrate how you can use this state machine. And I'll be also uploading this to the GitHub, of course, using on the Goblins game, so you can see an actual implementation of this system. But yeah, that's it for this video. I hope you like it, and I will see you on the next one. Bye.